Right, so today we're going to be looking at simultaneous equations. We've done a little bit of this already back when we were doing coordinate geometry, but it is really useful skill for your A-level. So two kind of topics we want to do today. So it's useful for finding where two curves or lines or functions meet. Or it's useful for solving two or more equations at once. Really key skill this, let's put that. Okay, so first up we're going to look at the easy ones, which are linear simultaneous equations. And we've done some of these already, so we'll go through this quite quickly. So there's two methods for solving these. There's what we call the elimination method and the substitution method. So I think substitution is what we did before, so we'll try that first. So we're going to try and solve these two equations simultaneously. So substitution first of all. So substitute, basically we're going to rearrange one of these to get y equals or x equals, and substitute it into the other equation. So because this one already has y equals, we're going to put this into this equation where it says y. So let's write that out again. So we get 4x minus 2 lots, and here we're going to put the y value from this equation equals 11. So you can see all we've done is replace this y with the value of y from the other equation. Now we can rearrange it and solve it for x. So 4x minus 10x minus 6 equals 11. So minus 6x equals 17. So x equals minus 17 over 6. Now we haven't fully solved it because we've only found x. We need to put this back in order to find y. So we'll do that over here. So y equals 5 lots of our x value plus 3, which gives us a y value of minus 67 over 6. So that's the substitution method. You literally get one variable and put it into the other equation and then solve it. And that will work with linear simultaneous equations or mixed of curves and lines. Alright, next up, the elimination method. So if this works, we should get the same solutions for this one. Okay, so the idea with the elimination method is we're going to either add these together or subtract these from each other in order to cancel out one of the variables. But to do that, we need to have the same amount of y's or x's in both equations. At the moment, we've got 1y here, 2y's here, or 5y's here, and 5x's here, and 4x's here. So the easiest way to do it would be to times the whole of this equation by 2 in order to get the same number of y's in both. So I'm going to times this equation by 2. So we get 2y equals 10x plus 6. And then I'm going to add this equation to this equation in order to cancel out the y's. So if I write them one on top of the other, and now we're going to add these two equations. So we get 4x, 2y minus 2y, they will cancel out, equals 10x plus 17, adding my 6 to my 11. We can then solve this because we've got an equation that only has x in it and rearrange to find what x equals. So take 10 from each side, so we get minus 6x equals 17, so x minus 17 over 6, and then we can substitute that back in to find the y value, which will give us the same thing as before, which was minus 67 over 6. So two different methods, substitution and elimination. Elimination can be a bit faster, but only works with linear simultaneous equations. Okay, let's try one more example of this one for another method of elimination. Okay, so again, we're going to try and solve this via elimination. So notice again, we've got 2x's here, 4x's here, 1y here, 2y's here. So we're going to have to times one of these equations by something in order to get the same number of x's or y's. If you guys want to pause it and give it a go for it, but I will try it now. So stop the video now if you wanted to try it yourself. So let's times the top equation by 2 so that we get 4x in both cases. So we're going to times this one by 2. So that will leave us with 4x minus 2y equals 2. And the other equation, 4x plus 2y, is minus 30. So I want to get rid of the x's this time, so we're going to subtract these two equations. So 4x take 4x, the x's will disappear. So 4x take 4x, they're gone. Minus 2y take 2y is going to leave us with minus 4y. And 2 minus minus 30 is going to give us 32. So y is going to be equal to minus 32 over 4, which is going to be equal to 8. And now we can find x by substituting this back into any of these equations we've used so far. So if we put this back up to here, we get 2x minus y, which is 8, equals 1. Add that to each side, so 2x equals 9, so x equals. Okay, so that's linear simultaneous equations, which works for when you've got two lines crossing on a graph. That's how we solve them. However, sometimes we're going to have curves crossing on a graph, and to do that we need to be able to solve quadratic simultaneous equations. So quadratic simultaneous equations will be used in a case like this, when you can expect to get two solutions for a line crossing a curve. So this results in two pairs of x, y solutions. And you can't do this using elimination, so you can only use substitution. So, for example, okay, so here we've got two equations. One has an x squared in it and has a function of x and y. The other is a straight line. So to solve this one, we're going to rearrange our line to get y equals, and then we're going to substitute that into the more complicated equation. So step 1, rearrange to get y equals or x equals. So I'm going to rearrange this one to get x equals 3 minus 2y. We're then going to substitute this into the other equation. So we get, so step 2, substitute into the other equation. We're going to substitute this into the other equation, wherever it says x. So we've got x squared at the beginning, so 3 minus 2y squared plus 3 lots of 3 minus 2y times by y equals 10. So this is this equation, but the x is substituted for our original equation. So we're going to expand this, get 9 minus 6y minus 6y plus 4y squared. Expand this one, plus 9 minus 6y, all times by y, equals 10. And then try and solve this equation. So 9 minus 12y plus 4y squared plus 9y minus 6y squared equals 10. So notice now we've got a quadratic that we're going to need to solve. So we've got minus 2y squared minus 3y plus 9 equals 10. And if we take 10 from both sides, now because all these terms are negative, I can add them all onto the other side of the equation and get 2y squared plus 3y plus 1 equals 0, which should be nice and easy to factorise. we go. So our solutions are going to be y equals minus 1 and y equals minus a half. And then we can substitute those back into either of these equations in order to find x. So x equals 3 minus 2 lots minus 1. X equals 5, or x equals 3 minus 2 lots minus a half. So x equals 3 minus 2 times minus a half. 3 plus 1, so x equals 4. Cool. Now you could do it the other way around. You could have substituted to get y equals, and then put that in there, and you'd get the same set of solutions. Okay, let's try one more of these as an example. Okay, so if you want to pause it and try it, feel free to do so. Pause it now. If not, we'll go through this. We've got a straight line and we've got a quadratic, and we're asked to state the coordinates where this curve intersects this, this line. So we're going to have to solve these simultaneously, and we might try and sketch these as well. So step one is we're going to rearrange this one to get y equals. So we rearrange and get y equals 3 minus x. And now we're going to substitute that into our quadratic. So x squared minus 3 lots of y equals 1. And we can expand this. And rearrange it to get a quadratic. So if we solve this quadratic, it'll tell us the x coordinates where the line intersects the curve. So solve this one, easiest way is to factorize it. So we've got factors of 10 that add to 3, so I think they're going to be 2 and 5. So positive 5 minus 2. So our solutions are x equals 2 or x equals minus 5. So we can now use these to find the y coordinates, because it does say state the coordinates. So we're going to put these back into this equation and get y equals 3 minus 2, which is 1, or y equals 3 minus 5, which is 8. So our coordinates are going to be 2, 1, and minus 5, 8. So if I wanted to sketch this, which I'll try and do now, you can see the coordinates match up with our intersections. Okay, so just to summarise this last bit. So as we've seen, the solutions to a pair of simultaneous equations represent the points where those equations intersect each other as graphs. So if you've got a graph, you've got a curve and a line intersecting, where they meet is going to be the solutions to their simultaneous equations. Now, so because of that, if a line and a curve intersect only once, their simultaneous equations will only have one solution. For example, if we had a curve, quadratic again, and for instance, what would be a good one? For example, this line, their simultaneous equations will only have one solution. If it has two solutions, it means it meets it twice. So here we could have one solution, two solutions, and no solutions. So you can see just by talking about simultaneous equations where things cross, you can also start getting the discriminant involved in these kind of questions as well, as you will see a little bit later. So we're just going to try, last of all, to mix up simultaneous equations with the stuff we did on discriminants in the last video to try and work out how many times a line and a curve intersect each other. Right, so again, if you feel like you can rush ahead and try this one, go for it, pause the video and try. We'll go for it. So does that line intersect that curve? So you might just try and solve them simultaneously, see if there are any solutions, but there's a quicker way. Because we've got a quadratic and a line, the simultaneous equations we'll have to solve will result in another quadratic equation. So if the discriminant of the resulting quadratic is positive, yes, they'll meet twice. If the discriminant is 0, they'll meet once. If the discriminant is negative, they won't meet. So let's try that out really quickly. So the simultaneous equation will be as follows. We can say 2x plus 5 equals 5x squared plus 4x plus 6. And now rearrange and solve this. So there's our resulting simultaneous equation. So if the discriminant of this, using the discriminant of this, we can find out how many times, if any, our curve and our curve and our line intersect. So here's our discriminant. So we get 4 minus 20, which is minus 16. So because the discriminant is negative, therefore there are no solutions, therefore no, the line does not intersect the curve. Okay, let's try one more, which is a pass exam question based on everything we've done so far. So, super hard question that kind of combines all these ideas. Find the k value, so here's k and here's k. That means the curve and the line only intersect at one point. So think back through what we've done today. Going to need to use simultaneous equations, going to need to use the discriminant. We're trying to find the k value that makes the curve and the line only meet at one point. So pause the video and give this one a go. Alright, so if they only meet at one point, it means that the discriminant of the simultaneous equation is going to be equal to 0 because it only has one solution. So the discriminant of the simultaneous equation has to equal 0. So let's start off with finding the simultaneous equation. So we're going to substitute 2x plus 1 into y, so kx squared plus 2 lots of 2x plus 1 plus k minus 2 equals 0. Okay, so the discriminant of the simultaneous equation needs to equal 0. So we're going to try and expand this and then find the discriminant. So expanding this one. So our 2's are going to cancel. So the kx squared plus 4x plus k equals 0. So because we have one intersection, the discriminant of this is going to equal 0. So working through here, we've got A, B, and C. The discriminant is going to end up as 16 minus 4 times k times k. So therefore 16 minus 4k squared can equal 0. So 16 equals 4k squared. So 4 equals k squared. So k is plus or minus 2. So if k is plus or minus 2, it means the curve and the line only intersect at one point. And we can prove that using GeoGebra. So we'll put in k as a slider and show what all this means and show what we found. So just to recap, because they only intersect at one point, means the discriminant of the simultaneous equation, because remember, the simultaneous equation is what's going to find where they intersect. And because they only intersect once, it means the simultaneous equation will only have one solution. Therefore, the discriminant of it will equal 0. So that's what we've done. We found the simultaneous equation, found its discriminant, set that equal to 0, and then use that to find the 2k values that make it only meet at one point. Alright, if you had any trouble today, watch back through the last couple of videos and then try the quiz.